Problem number 24 from the review paper for energy. I did not draw a picture for this one because there's already a picture on your review paper, but I will go over what the problem is. It's a 6 kilogram box of oranges. It's placed on a frictionless ramp. It's going to slide down the ramp and then hit a lower flat level below where there is friction. Our job is to find the force of friction acting on the box of oranges as it slides 19 meters to a stop. So the ramp is 5 meters high and it slides 19 meters along the flat surface before it stops. We're going to do this with energy. And what we will know is that initially this box of oranges is going to have potential energy because it's way up high, but it doesn't have any initial speed, so it's not going to have any initial kinetic energy. Later, when it gets to the bottom of the ramp, all of its gravitational potential energy will have gone away, but it's going to slide. Now, some people want to give it kinetic energy, but you have to remember that we are going to be looking at it after it comes to a stop. So not when it first gets to the bottom of the hill, after it slides for a while and stops. So its final speed is 0, meaning it's got no kinetic energy at the end of the problem either. And where did all that energy go? All that energy went away because of friction. So now we're going to expand our potential energy equation to what variables make that up, which is mgh. And the only thing left on the right side of the equation is the thermal energy, which is the work done by friction given by friction times the distance it slides. Now what we're looking for here is the force of friction acting on the orange crate. So we're going to have to divide our distance slid to the other side. So I get mgh divided by d equals my force of friction. I can plug in my numbers. The mass of the orange crate was 6 kilograms. Gravity is always 9.8 meters per second squared. The height of the ramp was 5 meters. And the oranges slid 19 meters before they eventually stopped. When I plug all that into my calculator, I should get that the force of friction is 15.5 newtons. And that's how we solve problem number 24.